Reliability and validity are important qualities of instruments. Validity refers to the appropriateness, correctness, meaningfulness, and usefulness of the specific inferences researchers make based on the data they collect. It is the most important idea when preparing or selecting an instrument. Validation is the process of collecting and analyzing evidence to support the inferences made according to the instrument results. There are three types of validity evidence. Next, let's look at each validity evidence. Content-related evidence. A key element here is the adequacy of the sampling of the domain it is supposed to represent. The other aspect is the format of the instrument. Attempts to obtain evidence from the items that measure what they are supposed to measure typify the process of content-related evidence. For instance, we can use a table of specifications to help us measure the accuracy of the content-related validity in an assessment-based instrument. Criterion-related evidence. A criterion is another test presumed to measure the same variable. There are two forms of criterion-related validity: predictive validity and concurrent validity. The specific form of criterion validity depends on the administration time of the criterion measure. We correlate the target measure with the criterion measure using correlation coefficients. A correlation coefficient indicates the degree of relationship that exists between the scores of individuals obtained by two instruments. For instance, we are interested in investigating the criterion validity of the BEST-TRSP, which is a screener in assessing preschool children's behavioral and emotional problems, in order to predict the performance of a criterion measure. In this instance, researchers would utilize a comprehensive and well-known behavioral assessment tool called the Child Behavior Checklist. We can correlate scores from two instruments to obtain criterion-related evidence. The correlation coefficients can be easily obtained in most statistical software. Construct-related evidence refers to the degree to which the evidence obtained is consistent with the theoretical expectation. It is considered to be the broadest of the three categories. Researchers attempt to collect a variety of evidence from different resources to help support the construct-related validity. Content-related and criterion-related evidence can be used to support construct-related validity. Please check the example. 3 steps are involved. Reliability refers to the consistency of scores or answers that are provided by an instrument. All measures contain some degree of inconsistency. This graph nicely illustrates the relationship between validity and reliability. Scores obtained can be considered reliable but not valid. An instrument should be reliable and valid depending on the context in which it is used. Because errors, inconsistencies of measurement are always present to some degree, variation in test scores are common. The variation is due to a number of factors including differences in motivation, energy, anxiety, and testing situations. The reliability coefficient expresses a relationship between scores from the same instrument at two different times or in different parts of the instrument. The 3 best-known methods for examining reliability are the test-retest method, the equivalent forms method, and the internal consistency method. Let's look at test-retest reliability. This involves administering the same test twice to the same group of individuals after a certain time interval has elapsed. The reliability coefficient is calculated to indicate the relationship between the two sets of scores. Reliability coefficients can be affected by the lapse of time between the administration of the tests. For most educational studies, we should aim for about 2 months between tests. The equivalent forms reliability involves two different but equivalent forms of the same instrument which are administered to the same group during the same period. Again, reliability coefficients can be calculated between two sets of scores. It is possible to combine the test-retest and the equivalent forms methods by giving two different forms of testing with a time interval between the two administrations. In practice, it is not realistic to offer the same instrument twice or parallel forms of instrument to the same group. Thus, we have internal consistency, which requires only one administration of one instrument. We can then calculate the split half reliability. We can score two halves of a test separately for each participant and calculate the correlation coefficient between those two scores. There are different ways to split the test, such as odd-even items. We can also use KR20 or KR21. KR21 is not that commonly used as it assumes the equal difficulty of each item. We will not cover how to calculate these indices in this course. You may see something called alpha coefficient or coefficient alpha reported in research studies. This is a general form of KR20, which calculates the reliability of items that are not scored as right versus wrong. Standard error is an index that shows the extent to which a measurement would vary under different or changed circumstances. There are many possible standard errors for one instrument depending on the reliability estimates. This is also known as measurement error. It is the range of scores that shows the amount of error inconsistency which can be expected. Finally, scoring agreement requires demonstrating that independent scores can achieve a satisfactory level of agreement in their scoring results. Instruments that use direct observations are highly vulnerable to observed differences. Such instruments usually need subjective scoring based on rubrics like performance tests. Instrument quality itself can be the subject of an entire course. Please think of this chapter as a brief introduction to the related concepts. You do not have to know how to calculate related indices at this moment. Just focus on your conceptual understanding for now. In your exam, I will not ask you how to calculate related coefficients. I may ask you to select the most appropriate type of validity evidence based on a particular scenario.